4.3 Properties of Logarithmic Functions Preparation continued. Alright, so this is just a review of the exponent rules. So we've already done these before. So the product rule states that if you have the same base and you're multiplying them together, you add the exponents together. So in this case, you would have the 3 plus 5, and that would give you 6 to the 8th power. Over here, you have parenthesis negative 4 in parenthesis 7th power multiplied by parenthesis negative 4 in parenthesis 2nd power. So you would add those powers together. So you'd say 7 plus 2, and that would give me negative 4 to the 9th power. Next, we have x squared times x. Again, we would add the exponents together. It's just in this case, there's an implied or understood one exponent on the second one. So you'd have x to the 2nd plus 1, which would give me x to the 3rd power. Over here, we have m to the 4th power multiplied by m to the 3rd power multiplied by m to the 5th power, which would be m to the 4 plus 3 plus 5, which would be m to the 4 plus 3 is 7, 7 plus 5 is 12, 12th power. Here we have 2 to the 3rd power times 3 to the 2nd power, and because they do not have the same base, you cannot use the product rule on this. Now you could say 2 to the 3rd power is 8, and you could say 3 to the 2nd power is 9, and 8 times 9 is 72. So you can't use the product rule, but you could just do normal PEMDAS, order of operation. Here, we have the same bases, 2 to the 3rd power, and we have 2 to the 4th power, but we're adding, and we're not multiplying, so we don't get to use the product rule. You can only use the product rule whenever things are being multiplied together with the same bases. So in this case, again, you would have to do order of operation. Exponents first. 2 to the 3rd power is 8. 2 to the 4th power is 16. 8 plus 16 is 24. But you wouldn't be able to use the product rule in either of those. Now, if you multiply, you get to use the product rule, right? But these coefficients you can multiply separately. So I'm actually going to break this apart a little bit. The coefficient 2 multiplied by the coefficient 3 on the second one. And then you have x to the 3rd times x to the 7th. Now you don't actually have to rewrite it or anything like this, but I just want to make it clear what's happening here. 2 times 3 is 6. So you multiply the coefficients together. 2 times 3 is 6. And then because you're multiplying these x bases together, you add their exponents together. So 3 plus 7, right? Or 3 plus 7 is 10. I'm actually even going to write that as a separate step. 3 plus 7 gives me 6, x to the 10th. Okay, so now we're going to review the power rule for exponents. So if you have a power to a power, you multiply them together. So in this case, you would say 2 to the 5th power times 2 to the 3rd power. You multiply the 5 times 3, and that would give me 2 to the 15th. Over here, you would say 5 to the 7th power to the 2nd power. So that is 7 times 2, which would give me 5 to the 14th. Over here, we would say x to the 2nd power to the 5th power. So that is 2 times 5, which gives me x to the 10th. Okay, rolling down a little bit more. We say power rule part B for exponents. So if I have two factors or more than one factor within the parenthesis to some power, you have to bring all the factors separately to that power, right? Which means you have to multiply their exponents together. Okay, so first one we end up with 3xy to the 2nd power. So it's going to be 3 to the 2nd power, x to the 2nd power, y to the 2nd power. 3 to the 2nd power is 9. So that gives me 9 x to the 2nd power, y to the 2nd power. Over here, because of order of operation, we have to deal with this exponent before we deal with the coefficient, okay? Exponents before multiplication, right? Okay, so in this case, we're going to keep 3 in front, but now we're going to end up with x to the 2nd power, y to the 2nd power. Okay, now we get rid of the parentheses, we end up with 3, x to the 2nd power, y to the 2nd power. Over here, we need to bring every one of the terms inside, all three of these, factors inside the parentheses to the 4th power. Now the first one is just going to take it on to the 4th power. But the other two, the m squared and the p thirds, they have their own exponent other than 1. Now technically, the 2 has a 1 exponent, so 1 times 4 is 4, right? So the rule still applies. Normally you just don't see it though. Okay, so in this case you're going to have m 2 times 4, p 3 times 4. And that gives me, well, 2 to the 4th power is simply a 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16. Right? M2 times 4 is going to give you an 8, and P to the 3 times 4 is going to give you a 12. Right? It gives you a 12. Okay, over here, we end up with a negative 5 to the 6th power, within parentheses, all to the 3rd power. So you're going to keep the negative. Now, the reason you keep the negative in this case is because you're bringing it to an odd power. If you would have brought the negative to an even power, you would have gotten rid of the negative. Okay, so then it's going to be 6 times 3, which is, 6 times 3 is 18. And there you go.